Hi everyone, welcome back to the channel. Today we're going to compare the very popular GitHub Actions to the Semaphore Community Edition to help you decide which solution works best for you and your team. As I said in a previous video, when I compared Jenkins to Semaphore, the goal is not to find the best CI/CD, but which one fits best for your use case. The video consists of two parts. The first half will compare the process of setting up jobs, pipelines, and compare features between Semaphore Community Edition and GitHub Actions. In the second half, we're going to go to the on-premise or self-hosted part, and we're going to compare the installation process for GitHub Enterprise Server and for Semaphore Community Edition. So setting up a new project in GitHub Actions is pretty easy. You already have the code in repository, and creating a new workflow or pipeline is very easy. There are a bunch of starter workflows created by GitHub and by third parties. Once we select the appropriate workflow, we're presented with the YAML code that defines the pipeline. On the left side, we have the code editor. On the right side, we have snippets for different kinds of actions, which are the core of GitHub Actions. In GitHub Actions, everything is an action. This is the basic unit of work. If we want to clone the repository, we need to call the checkout action, for example. This means that you need to know which action does what, and this adds a little bit of complexity to setting up your project. In Semaphore, we also have starter workflows for different languages and frameworks, but what makes Semaphore very different is that it has a built-in visual mode, it has a visual editor, it's called the workflow editor, and this is a full-featured editor that lets you build the pipelines visually. And as far as I know, Semaphore is the only CI/CD product with this feature. Behind the curtain, Semaphore uses its own YAML format, and while you can edit the YAML directly by hand, you usually don't need to because the built-in editor is full featured, and there's almost never any need to edit by hand the YAML. Another big difference is that Semaphore Community Edition does not use actions like GitHub Actions. Instead, we put in each job. Each line is basically a command in a bash session. So whatever scripts, whatever commands you usually run in your Linux machine or macOS machine, you can copy that into the pipeline and it will work as intended. So removing this action abstraction layer makes setting up your job much more straightforward. So let's talk a little bit about parallelization in GitHub Actions. By default, all jobs run in parallel unless we put dependencies between them. We declare dependencies with the needs keyword. In this example, the deploy job runs after the build job, so it's pretty simple to understand. Semaphore has a similar behavior with the difference that jobs always exist inside what we call a block. A block is simply a group of one or more jobs, and all jobs in the same block run in parallel, each one in a different isolated environment. If we want to put jobs one after the other, we declare dependencies at the block level. So we put simply by clicking on one of the blocks, we can make the block run after all the jobs in the previous block have finished. So let's discuss now features. I will start with Git support. So GitHub Actions is integrated into GitHub. There is no way to connect to any other Git provider like Bitbucket or GitLab, and it makes sense for GitHub if you are using that, but it also locks you into their ecosystem. Semaphore, on the other hand, can work with any Git provider. It has easy integrations with GitHub, Bitbucket, and GitLab, but it can connect with any Git server that uses SSH. So as long as SSH is a connection method, Semaphore can work with that repository, with that provider. This means you can switch version control providers without losing any of your pipelines. Monorepo support. Monorepos are repositories that contains more than one project. They are usually independent from each other. The big problem with monorepos and continuous integration is we don't want to rerun all the pipelines, all the jobs when I only modify one project in the repository. So we need to find some way for the pipeline to recognize which jobs need to run and which one can be skipped because the code has not changed. GitHub Actions and Semaphore, they both support monorepos, and we're going to see they implemented a little bit different. So GitHub Actions implement monorepos using what's called a path-based filtering, which allows a job to run when some file or some directory has changed in a given push. In this example, we are only running the job when a file in the frontend or the shared directories has changed. This path filtering feature works with the main trunk, with feature branches and pull request. One thing to consider is that the checkout action may need to be modified because by default it does a shallow clone, and that can mean that we miss some commits. So we usually need to also change the fetch depth parameter. So in this case, for example, we are setting up to check out the last 5 commits. This behavior means that we need to get the fetch depth right in order to get all the commits that are relevant to decide if a job runs or not. In practice, this might involve implementing some custom logic or use some specialized actions to handle this complexity of determining the proper comparison points. Semaphore also has monorepo support. The implementation is a little bit different. We use the change in tool. This is an open source tool that runs before the pipeline begins. Changing only needs a list of matching paths. It can be paths. It can use globing to match patterns, directories, and files in your repository. We don't need to supply any fetch depth, as automatically this tool will pick the most conservative strategy to be sure that it's capturing all the relevant commits. Changing is something that we set at the block level, and it will return either true or false. If it's true, it means that the job will run. If it's false, it means that the job will be skipped. And the behavior of this tool depends on what kind of push we're doing. If we are, for example, pushing into the main trunk, like main or master, changing will inspect all the commits that are present in the push that trigger the workflow for future branches and pull requests. Changing inspects the commit range, starting from the common ancestor between the branches and the head of the push branch, so it always gets all the relevant commits. We can also customize the behavior of changing by supplying options, for example, what to do if the pipeline itself changes, what files to exclude, what is the name of the main trunk, main branch, and what to do when Git tags are pushed. Test dashboard. A test dashboard provides a single place where we can see all the test results across all the CI runs. GitHub Action does not have any built-in dashboard. We need to implement some third-party solution or get a plugin from the marketplace. Semaphore processes all the test results in your test suite across all CI runs for your project, and it lets us filter by duration, category. We can search by name. We can see basically in a single place all the tests across all the categories in our project. Custom reports. GitHub Actions, as with test reports, does not provide any way to customize or create and generate a customized report. This is something that Semaphore does provide. We can create reports dynamically inside the CI job and export that into the platform, and it will render the report next to our pipelines. This is a feature that's called in Semaphore are called Markdown reports, because they use Markdown as the language for rendering reports, and we can generate graphics and diagrams using Mermaid.js. It supports this language. We can, for example, create Gantt diagrams. We can compute utilization metrics, create dependency graph, coverage diagrams. We can embed images, tables, anything really that we can render in Markdown can work as a report on Semaphore. Notifications. Both GitHub and Semaphore can send notifications via Slack, and it's quite easy to set up. Both platforms also implement webhook-based notifications, so we can, for example, send notification to Microsoft Teams or Discord or anything really that supports webhooks. And in addition, GitHub supports email notification and push notifications in their mobile applications. Now let's move to part 2, where we compare how to install Semaphore and GitHub Enterprise Server in our on-premise machine or our cloud machines. Let's start with the license. To install GitHub on-premise, we need a license for the enterprise servers, which is a commercial license. So Semaphore Community Edition, on the other hand, is distributed under the Apache 2 license. This is a very permissible license. It's free, it's certified open source, and it allows you unlimited access without paying a dime. Now, let's talk about hardware. What hardware do you need to run both platforms? GitHub Enterprise Server is pretty beefy. It requires at least 8 CPUs, 48 gigabytes of RAM. This depends a little bit on the expected usage, but for 100 users, you need at least this amount of memory. And usually storage goes from 200 to 300 for your data. So Semaphore requires a lot less hardware to run. We can install it on a single Linux machine with 8 CPUs and 16 gigabytes of RAM. This is enough to serve several users and to run the control plane. And if we need more capacity, we can install it on a Kubernetes cluster, and we can even enable auto-scaling using AWS EC2 machines. Installation. GitHub requires pretty specialized hardware and software to run. We need either a VMware ESX installation or a vSphere hypervisor. We can also run it on OpenStack or on Azure. For Semaphore, the prerequisites are more standard. We only need a domain, so we can create a certificate. We need a public IP address, and then we need either a K3S to run a Kubernetes cluster on a single node or a Kubernetes cluster proper, and then we can deploy Semaphore using Helm. The installation usually takes about 10 minutes. Redundancy. GitHub provides high availability using an active standby node using replication and a backup service. In the case of Semaphore, the resilience is built in. As long as you use a Kubernetes cluster, the availability of your Kubernetes cluster is the availability of your Semaphore instance. So there you have it, a side-by-side look of GitHub versus Semaphore. Obviously, each one has its own strength. GitHub Enterprise, for example, provides the whole package, but it kind of locks you in into their ecosystem, and it's not open source. Semaphore CE only provides the CI part, but specializing in the CI part allows us to provide more features to you. Also, Semaphore Community Edition is open source, it's completely free, it's feature packed, and can work with any Git provider. So if you're worried about vendor lock-in, Semaphore is a great alternative. That's all for today. Don't forget to like, subscribe, and hit that bell button so you don't miss anything. Take care and see you next time.